Okay, so we are going to talk about the polar coordinate today, which is different from the x and the y coordinate that we used to learn. So what is polar coordinate? It has two values. One is radius and the other one is theta. As long as you have these two, just like x and y coordinates, you will know where the point will be and what the function will be looking like. Let me draw a coordinate here. Okay, let's assume today we have a function which is r equals to 1 minus sine theta. So how does this look like? So first of all, we can put number into theta. Then we will know the value of r. So we will know both r and the theta. So first of all, I will write down theta and r's value. For example, when theta equals to 0, which means your r will be 1. Okay, so when your theta equals to pi divided by 2, which will be your sine theta will be 1, right? So 1 minus 1 is 0, so your r will be 0. And then let's keep moving. So when your theta equals to pi, which your sine theta will be 0, so it goes back to 1. Okay, that's continuing. Theta r. So when your theta equals to, let me see, 3 over 2 pi, it will be minus 1. So when your theta equals to 2 pi, which send as 0, and it will be 1. Okay, so now we have the value, so we can put it into our coordinate. So when your theta is 0, okay, theta 0 is here. Let me change a different color. Okay, it will be here. Here will be your 0. Okay, 0 degree, and your r is 1. Okay, let's draw a circle, which let's assume its radius is equal to 1. Okay, good. Then let's draw another circle, make it bigger, and make it radius equals to 2. Okay, now it looks equals to 2. Now let me move it a little bit. Yeah, probably here. Maybe on the right side a little bit. Okay, and I will change the transparency so it will not be too obvious because these are just for reference. Okay, so first of all, when your theta, not this. Okay, so when your theta equals to 1, your r, no, sorry, when your theta equals to 0, your r is 1. So 1, 0 is here. Okay, so when your theta becomes to pi over 2, it will be, your r will become 0, which will be here. Okay, let's write it down. Oh, sorry, r first. So 0, 0, pi divided by 2. Okay, and then we go to next one. When your theta is pi, your r will be 1. Okay, here, 1, and the pi. Okay, so let's go over to 3 over 2 pi, which your r will be minus 1. Oh, sorry, here is not minus 1. I mean, like, sine theta is minus 1. So it will be 2 here, which is here. Okay. Your 3 over 2 pi, and your r is 2. And let's see here. So you can see as the angles go bigger, the radius actually decrease. So you'll be looking like when it's 1, right? And it gradually decrease until 0 here as it rotates. And here is increase. Okay, increase. So it will be looking like this. You increase from 0 to 1, the radius. And then when it goes to 3 over 2, it's also increase. So which your radius increase like this. Oh, here is a little bit overlap. Okay, and then now from 3 over 2 pi to 2 pi is actually decreased. Should be looking like this. Okay, so now we draw the heart shape based on the polar coordinate. So this is how the polar coordinate work. But moving forward, how do we calculate the area of it? So let's see. Where is the area? Okay, let me... Oh. Maybe it's not all connected. Let me check. Make sure they connected. Oh, it's not the same. I see. Now the same layer. Okay, now it's good. Okay, cool. Now I can change the transparency. So, to calculate this area, let's make them all smaller. So, to calculate this area, it's pretty simple. We all learn the integration, so we will know if we want to calculate the area, it will be integration from 0 to 2 pi. And we all know the area of the circle, which is 2 pi r. No, sorry, this is circumference, which is pi r square. And then we also know one round is 2 pi. So we need to divide it by 2 pi. 1 over 2 pi. Because then this will be the proportion, and this will be like how much. Okay, and with respect to theta. So we all know, let's plug in the r value. Here is 1 minus sine theta. Integration from 0 to 2 pi. And then here will be 1 over 2. This is square with respect to theta. Which we will see here is 1 minus 2 sine theta plus sine theta square. Integration from 0 to 2 pi times 1 over 2 with respect to theta, which will be 1 over 2 integration. Okay, maybe we can do the integral this already. So it will be theta. And then minus 2 times sine theta will be cosine plus 2 times cosine theta. And then we will have 1 over 2 integration from 0 to 2 pi sine theta squared with respect to theta. Make it smaller. So now let's see. Okay, so I can make it smaller later. Which this one will be, oh sorry, here will be your from 0 to 2 pi. So let's see. When you plug in the 2 pi, here will be pi cosine 2 pi. Cosine 2 pi is 1, which is 2. 2 minus 2 is 0, so which is 0. Okay. So now we have to plus 1 over 2. Integration from 0 to 2 pi. And we all know sine theta squared will be 1 minus cosine theta. 2 theta actually, over 2 with respect to theta, which will be pi plus 1 over 2 integrate times integration from 0 to 2 pi. Actually, you can move the 1 over 2 in front, which will be 1 over 4. And then 1 minus cosine 2 pi with respect to theta, which it could be 2 theta. And here need 2 times 1 over 2, which will be pi minus 1 over a times integration. Maybe I can do this already. And then 2 theta. And then here will be, let's see, will be your sine theta. 2 theta, sorry, sine 2 theta. Okay? And here is from 0 to 2 pi. So let's plug it in, pi minus. So when you plug in the 2 pi times 2, so which will be 2 over pi. And then minus, okay, sine 2 pi is 0. So which is 0. Okay. So no need. Which will be, oh, no space. Yes, still space. Okay, 3 over 2 pi. Make it smaller. Oops. Okay, I will put that later. 0, 2 pi. Okay, so